Welcome to another video. I hope y'all are doing better than I am. Today we'll be doing exercise 1H. We're finally on factorials. This is getting into the binomial theory, but right now, just factorials, that's all we need to focus about. So let's get this started. Number 1 is asking us to copy the table down and basically solve the equations. I'm not copying it all down, but I'll write it like this. And basically, just asking us to find a way to factor it out and solve. This can be factored out like this. Since if you remember, 9 factorial is just 9 times 8 factorial. And it actually does want you to put in the answer at the end, so we'll do that. I already have all this calculated, by the way, so this isn't really something I need to waste time on. 7 factorial minus 6 factorial is going to be equal to 6 factorial times 7 minus 1, which is equal to 4,320. Six factorial plus 5 factorial is going to be equal to 5 factorial times 6 plus 1, which is equal to 840. Okay, now we're taking away the numbers because IB loves to do this stuff to you. N plus 1 factorial minus n factorial. That's going to be equal to n factorial times n plus 1 minus 1 factorial. Or minus 1, which is just going to be equal to n times n factorial. Then we have n factorial, that's not an n. N factorial minus n minus 1 factorial, which is going to be equal to n minus 1 factorial times n minus 1, which is just equal to n minus 1 n minus 1 factorial. That factorial is on this, by the way. Then we have n factorial plus n minus 1 factorial. We can take an n minus 1 factorial out of all of this and then multiply by what we had earlier. And that's our answer. Now for our last one, we're going to have n plus 1 factorial plus n factorial, which is equal to n factorial n plus 1, which is equal to n plus 2 times n factorial. That is that. On to number 2. Number 2 says to find the value of all of these, so let's start. 2a, we have 8 factorial over 4 times 6 factorial. Remember, with factorials are just 8 times 7 times 6 times 5. So this is going to be 8 times 7 times 6 factorial over 4 times 6 factorial. These cancels out, and we're just left with 8 times 7 divided by 4, which is 14. 2b, 4 factorial over 5 factorial times 3 factorial times 6 factorial, which is then going to be equal to 4 times 3 factorial times 5 factorial over 3 factorial times 6 times 5 factorial. All of that cancels. We're left with 4 divided by 6, which is 2 over 3. 2c, we have 10 factorial times 8 factorial over 11 factorial times 6 factorial. Remember, this is going to stay 10 factorial, but now our 8 is going to become 8 times 7 times 6 factorial, and down here is going to become 11 times 10 factorial times 6 factorial. Cancel all of this out. Left to 8 times 7 divided by 11, which is just going to be 56 divided by 11. Okay, on to 3a. 3a asks to simplify the following. Once again, this time we're in variable form. Sorry. Okay. N plus 1 factorial over n factorial minus n plus 1 factorial. Okay, our denominator is going to stay the same for a second. However, our denominator is just going to be equal to n factorial times 1 to get that n factorial minus n plus 1 to get that negative n plus 1 factorial. And once we cancel out terms, we'll end up just getting n plus 1 over n. All right, next one. 30b. We have n factorial plus n plus 1 factorial over n factorial. This time the numerator is going to change, and we're going to factor out an n factorial from both sides, or from the top, and multiply that by 1 plus n plus 1 divided by n factorial. Those cancels out, and that just gives us n plus 2. 3c. We have n factorial squared minus 1 divided by n factorial minus 1. And that's just going to be equal to n factorial plus 1. Remember, plus 1 times n factorial minus 1. The reason this is true is because when a squared minus b squared, that's going to be equal to a plus b, a minus b. Always remember that. What about n factorial minus 1? Cancel those terms out. We get 1 plus n factorial. Okay, on to 4. It's asking us to show this super long equation that I don't want to write, but I don't have a choice. So let's go ahead and get started. We have 2n plus 2 factorial, n factorial squared, brackets n plus 1 factorial, brackets squared, 2n factorial. Okay, first step here. What's going to be the first step here? All right, first step here is to get everything going. Let's just simplify all of these terms. So we'll have 2n plus 2, 2n plus 1. Now 2n factorial, look at that. N factorial. N factorial divided by n plus 1 times n factorial times n plus 1 times n factorial times 2n factorial. Cancel out some terms here. Cancel these out. we're left with 2n plus 2, 2n plus 1 over n plus 1 squared which is just equal to 2n plus 1 divided by n plus 1. And that's simplified, I should mention. Okay. On to number 5. Oh, sure, I forgot to actually say. Basically, we were proving that this entire thing equals that. That is in fact the proof for it. I should elaborate a bit further on this. Nah, it's fine. Just know that it simplifies to that. Okay, number 5. We're going to combinations now for n, which is an element of a positive integer. We're going to have n choose 2 divided by, or n that, or n to n factorial, n minus 2 factorial. 2 factorial is equal to 66. And our task here is to find out what n is. You know that n factorial, n minus 2 factorial is going to be equal to 132. And n factorial is going to be equal to n minus 1 minus 2 factorial minus 2 factorial. Those cancels out. So then that means n minus 1 is equal to 132. We can set up a little quadratic equation. N squared minus n minus 132 is equal to 0. You have n minus 12 and n plus 11. That means n is equal to 12 since n has to be a positive integer. Okay, on to 6. Solve this equation that is giving us. We have 16 n minus 1 factorial is equal to 5n factorial. Is that a plus sign? Yep. Plus n plus 1 factorial. Okay. You know, let's see, how can I fact this out? Okay, I see how. We have a 16 n minus 1 factorial on this side. So this side, we also want to get an n minus 1 factorial. And we can do that by setting it like this. That's supposed to be factorial. So then we divide by that on both sides. We get 16 is equal to 5n plus n plus 1. 16 is equal to 5n plus n squared plus n. We get another quadratic equation. So we get n squared plus 6n minus 16 is equal to 0. That factors out to n plus 8 and n minus 2. Since n has to be an element of a positive integer, we get n equals 2. Okay, 7. On a bookshelf, there are 4 mathematics books, 3 science books, and 2 geography books, and 4 history books. The books are all different. 7a asks us, in how many different ways can the books be arranged on the shelf? Okay. since it's just asking how many different ways the books can be arranged, we're going to add up every single book there is, well, each different kind. So we'll start with 4 math books plus 3 science plus 2 geography and 4 history books. That equals 13. And then to arrange 13 books in different ways, it's going to be 13 factorial. 7b says in how many ways can the books be arranged so that the books of the same subject are grouped together. To do this, we first start with math. We know that there are 4 math books, and if they need to be grouped together, that means that there are 4 factorial ways to set them up first. And now we're going to have to multiply that by the rest of the probabilities. So we have 3 factorial ways for, science books, times 2 factorial ways for history books, times 4 more factorial ways for history books. 2 is the geography books. Sorry. And then we're going to actually end up multiplying it by 4 factorial one more time due to the fact that the math books could well, these are the math books. This 4 out here is for basically just how many ways we can arrange it in groups. There's going to be 4 groups here. So that's the amount of different ways they can be in groups. Sorry. And that's around 1,000. Okay, I think it's 1,404,000. Yep. Okay, on to 8. A safe has 2 dials, one with 26 letters and one with digits 0 to 9. In order to open the safe, Rose has to choose a code consisting of 3 distinct letters followed by 2 distinct digits. Determine how many different safe codes are possible. Okay. Since it has 26 letters and the code is consisting of 3 distinct letters, this means that the letters, doesn't matter which ones they are, but since they're distinct, they do have to be different each time. So first, she has 26 letters you can choose from, then 25 letters, then 24 letters, and then we're going to multiply that by the amount of numbers. It says 2 distinct numbers. So if it's from 0 to 9, that's 10 digits. So that's 10 numbers she can choose, and after she chooses a digit, she can't choose another, or she can't choose the same digit, so that's going to be times 9, and that's going to be equal to, oh, I did my math wrong. I looked at the wrong thing. That's equal to 1,404,000. This is equal to something completely different. I have it on a sheet of paper right here, and I look at it to just confirm my answer, so got it mixed up. Sorry about that. That's the answer for both of them. Okay, 9A. A delegation of 5 students is to be selected for a Model United Nations conference. There are 10 boys and 13 girls to choose from. 9A is asking us, in how many different ways can a delegation be chosen if there are no restrictions? Okay, no restrictions. That's going to be a combination thing. That's just going to be 23, choose 5. We choose 5 random people. And after doing the math for that, you should get 33,649 different ways. 9B is now saying if the team is to include at least 1 girl and 1 boy, in how many ways can the delegations be selected? Okay. For this, we're just going to basically do subtraction here, where we find the amount of, or how many ways there are choosing all boys, how many ways there are choosing all girls, and then the number of ways of choosing at least 1 boy and at least 1 girl. And to find out the number of ways of choosing at least 1 boy and 1 girl, we're going to take our total ways of choosing them at random and subtracting it by our amount of ways of choosing all boys plus amount of ways of choosing all girls. So for all boys, that's going to be 13, choose 5. Girls, that's going to be 10, choose 5. And as we said in our last one, for no restrictions, it's going to be 23, choose 5, minus 13, choose 5, plus 10, choose 5. And when you do the math for this, you'll get 32,111. Okay, on to 10A. 10A says, and how many 4-digit numbers can be made using the digits 0, 1, 3, 4, 5, 8, and 9. Okay. Since it's going to be a 4-digit number, we're going to have to take out 0 from here in our first little thing. There's 1, 2, 3, 4, 5, 6, 7 digits to use from. But since our first number has to not be 0, that means there's only 6 digits to choose from. And from there on out, there's going to be 7 digits to choose from. And then after that, another 7 digits, and then another 7 digits, which is just 6 times 7 cubed, which is equal to 2,005 or 58 different numbers you can make from that. 10B is now including restrictions. How many of the 4-digit numbers have no repeated digits? This is going to be our first. So first we choose a number out of this list that's not 0, so it's going to be 6. Then after that, originally we would have 7 numbers for this next, but now we're only going to have 6. And now that we chose 2 already, we're going to be left with 5 numbers, and then left with 4 numbers in the end, which is 720 different ways for none of them to have repeated digits. 10C, how many 4-digit even numbers can be made using the digits? Okay. If it's an even number, that means the last digit has to be either 0, 4, or 8, since those are the only divisible even numbers that are given to us. Basically, it's going to be the same thing as 10A at the beginning. It's going to be 6 times 7 times 7. But then at the end, there's only 3 numbers to choose from, so it's times 3 here. And it's going to be 882. Okay, last one. 10D. How many of these even numbers are divisible by 5? Okay, remember, for a number to be divisible by 5, the last digit has to either be 0 or 5. Since we do not have a 5. Oh, no, we do have a 5 on our list. Right? I'm not making a mistake. How many of these even numbers are divisible by 5? Shoot, wait. Oh, okay, that's where I was making the mistake from. Okay, how many of these even numbers can be divisible by 5? For a number to be divisible by 5, it has to either end in 0 or 5, but since it's an even number, it can't end in 5. So it has to end in 0. And doing what we were doing last time, they can be any number at the start, but we only have one possibility for the end, and that's 0. It's going to be 290 ways. Boom. That's a 90. 11. Let me read 11. Okay. Grammy is training for a 10-kilometer run. He has 6 different routes. Okay, so 6 routes for his training. And he trains 4 times a week, 4x a week. He calculates that he will manage to run a different set of routes each week leading up to his... he calculates that he will just manage to run a different set of routes each week leading up to his next race. How many weeks are there before Grammy's race? Okay. Since he has 6 routes and he's actually able to choose 4 of these routes, we know this is going to be a 6 choose 4 situation here. The thing is, whether it's just a combination or a permutation, since order does not matter, you can choose any of these routes that you want, and it didn't tell us otherwise. We know that it's going to be a combination. And in this case, this is going to be our answer, 6 choose 4, and that is equal to 15. So that means there are 15 weeks left. Okay, 12. A group of 12 people want to go to a concert. They can travel in a small car that takes one driver and one passenger, and 2 cars each taking one driver and 4 passengers. If there are 5 drivers in a group, how many different ways can they travel? Okay, this one's a bit more complicated, but we first need to find out how many ways there are to choose drivers in the group. They only have a small car, that can take one person, so that's 2 in general, and then they have 2 cars, they're a bit bigger, that can take 5 people including the driver. Okay, so there are 5 choose 3 ways to choose a driver. This means that there are 9 ways to choose a passenger for the small car. Because after you've already chosen, how many people did they have in their group? 12 people, yeah. After you've already chosen 3 of those drivers, there's going to be 9 people left. And then there's 9 ways you can choose who's going to become the passenger for the small car. So that means that leaves 8 people left for these 2 cars. And we're going to just assume that they're not splitting evenly into these. Wait, no, they are splitting evenly. 4 people go in one car, and then 4 people go into the next car. Therefore, we can create an equation here where we have 8 choose 4. Actually, let's start from the very beginning. We have 5 choose 3 for how many drivers there could be. And that's going to get multiplied by 3 factorial because because there's going to be 3 cars, and those 3 drivers can decide which car they're going to choose to go in 6 different ways, which is 3 factorial ways, times 9 for the amount of people left, times 8 choose 4 factorial to see who's going to go into the first car, times 4 choose 4 factorial, because there's only going to be one way all those passengers can get in, and that's going to end up being equal to 37,800. And that is how many different ways they can actually travel. That's going to be the end for this exercise, and I hope you enjoyed.